Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Theodore from Business Review, and I will be your host. It's our pleasure to have ENEXSA with us today, who will be presenting this webinar entitled Business Critical Settlement Systems. Today, guest speakers are Dr. Joseph Petek, who is Manager Commercial Operations, and Dr. Peter Hartner, who is Manager Software Systems. Now, please allow me to welcome Joseph.
Thank you very much, Theodore. Good morning or good afternoon, ladies and gentlemen. Thank you very much for joining this webinar. My name is Joseph Petek, and I'm very pleased to welcome you on our webinar on business critical settlement systems for independent power and water plants. Let me give you a quick overview about the agenda of our webinar. First, I want to introduce our company, but then I'll go right into the topic, giving a little overview of power purchase agreements or water purchase agreements. And then I will hand over to Peter Hartner to give you some demonstrations and some more detail on the key qualities that enable the settlement process through our settlement software. He will also include a short session on performance models, which are a part of settlement systems. And finally, we'll give some overview of the experience that ENEXSA has gained during the last decades, I can already say, in this field. Finally, but very important, please feel free to enter questions if you have any during the webinar or after the webinar. There is a Q&A option. You can ask your questions, just type them in, as Theodore explained, into the respective input sections of your web browser. ENEXSA is actually a new company name that we have chosen since the year 2019. Some of you may already know us under a different name, VTU Energy. In 2019, the core team of the company took over the company in a management buyout, and we renamed ourselves ENEXSA, which is an abbreviation for Energy Expert Software Applications. And this name actually comprises very well the content and our capabilities of our company, as we are offering expert consultancy and software systems for the power industry. We are currently a team of 21 persons, even more than shown on this picture here. Our office location is in Graz, Austria. And our offerings, our portfolio is widespread. We are in the power industry, and we focus on consulting based on thermodynamic simulation. The subject of our webinar today, fuel demand models and settlement systems for IPP and IWP. But we also do plant simulation models in general. We are co-developing heat balance software, and we build optimization systems. As we are a software developer, there's lots of room to customize our products and services to the applications. And as you can see from the pictures shown in this slide, the range goes from gas turbine-based power plants, or in this case, an IWPP, a combination of a gas turbine combined cycle plant with an RO desalination units. We have special customized heat recovery boiler shown on the upper right. Many of you from the Middle East region may know the plant shown on the lower left. That's the Shams 1 power plant, the first solar power plant in the Middle East. And lower right, we are of course in the era of Energiewende, so the power industry is changing. We have solar power, we have wind power, we will need battery storage to manage the power systems of the future, and electrolyzers to produce hydrogen may also be a very core part to that, and all of that actually is part of our engineering portfolio. And the tool that we are using to simulate, to model these processes is the Epsilon professional heat balance software by STEAG Energy Services of Germany, which is co-developed by ENEXSA. And as such, as a consultant, we actually have access to our own tools. And frankly speaking, and maybe you have watched our last year's webinar together with Peter Bechtel, I was presenting the technologies that we develop around Epsilon. We are really our hardest customer ourselves. We are pushing Epsilon and our technology to the limit in order to improve our tools and to improve productivity and provide perfect solutions for our customers. The Epsilon software was also the entry part, or the heat balance modeling was the entrance part into the business of settlement systems, as we were, as an expert consultant, producing fuel demand models since many years. And in the year 2007, we started our first settlement system project, where we then supplied both the fuel demand model and the settlement system. Peter Hartner was involved from the beginning. He did all the conceptual design and went through all the design phases. So in today's webinar, he's the real expert on the settlement system. He will show during the demonstration what we can really achieve with our systems. ENEXSA is based in Graz, Austria. You see a little red dot in the center of this map. We are based in Austria, in the center of Europe, but our customers and projects are widespread, actually all around the globe, from the west coast of the USA to Japan. You can see many locations of our projects and customers. And our portfolio, as I mentioned, heat balance simulation, we have customers for our software tools, big names, OEM like GE, Mitsubishi Power, Ansaldo are using our heat balance software and add-on libraries for the Epsilon software. We have customers for consulting projects like the Austrian oil and gas company OMV, Austrian steel company voestalpine, STEAG, as we are co-developing with the Epsilon software. We also did consultancy for them. Then we have, of course, and you see big names here in the field of independent power and water projects, Mitsubishi Corporations, Marubeni, Mitsui, Sumitomo, Sembcorp, Aqua Power. That's actually customers in the field of plant accounting and settlement systems and fuel demand models. And the yellow dots in the world map shows the spread of our settlement systems. So from projects in Morocco, where we did the newer settlement systems for the new projects, key or around the Arabic Peninsula, of course, all countries around the Gulf region, we have supplied settlement systems, and also settlement systems first of a kind in Bangladesh and Myanmar. We'll come to the details later. So we are very experienced in the field. We have international customers, and as such, we are doing this business very long time with recurring customers and hopefully very happy customers in that field. Coming to the topic of today's webinar, I'll give a short overview and introduction to power purchase and water purchase agreements. The projects that we are dealing with such systems are public-private partnership projects. So the country, the government of a country decides to partner with private investors in large infrastructure projects. This PPP project approach has been a success story in many countries, in particular in the Gulf region. If you look since the late 1990s, where the first independent power project started, there has been a continuous growth in power production, no issues with capacity shortages, and the tariffs and prices for electricity and water have been kept at a very competitive range because of the competitive nature of these projects. So large tenders ask for international investors to participate in these projects. The worth of such projects go into the billion USD range. If you look at 2,000, 3,000 megawatt projects or projects with desalination plants in the range of 200 MIGD. So this is several hundreds of millions or even billion-dollar project worth. And this is, of course, an investment that is reflected in the tariff, in the power and water purchase agreements. The tariff equations define the monthly payments to the project company, to the developer, that shall pay back all the initial investment and the ongoing cost of the project. The production of these independent power and water plants is under the dispatch of the respective grid operators in that country. So it's not the choice of the plant to decide or to choose the most profitable way to run. So it is a full dispatch from external, and therefore there is, beside the actual production numbers in terms of megawatt hours and MIGD, there is other components in the remuneration of the independent power and water plants that accounts for performance, to make sure that the plants are operated in the most effective way and maintained very well, and as well as availability, because of course capacity and availability is most important in countries of this harsh environment, of this climate, where water and electric power for air conditioning are essential for the countries. So the components these components need to be covered, and the power and water purchase agreements account for that in an hourly accounting for production and consumption of these plants to be converted into the monthly payment to the project company. The tariff equations of the settlement system of the purchase agreement therefore also relate to these key areas. So there is payment components on the pure production, but as I mentioned before, as the plant are dispatched externally, this is not the full payment. It is oftentimes the case that the plant run at low load just to be available in spare capacity or spinning reserve. So production alone does not pay back all of the efforts of the plant. So there is also payment components for availability and performance, as well as operation and maintenance for the O&M company. And each of these aspects is reflected in the respective payment components to be processed on an hourly basis in the settlement system. Also, there is additional terms for special events that are included in the contract. So the settlement system also has to account for such special conditions. With that, we come to the core point of our webinar, explaining to you the key qualities that enable the settlement process. And for that, I want to hand over to Peter Hartner, who is the manager of software systems at ENEXSA, to give you his thoughts and provide some demonstration of our settlement system. Peter, please go ahead.
Thank you very much, Joseph. Welcome everybody to this webinar. Let me start with the key qualities, as Joseph mentioned. We have listed 5 items which we think are responsible and important for quality of the settlement system. The first one is reliability. Obviously, at the end of the month, as Joseph mentioned, the money stream is determined by the settlement system, so you want to have a timely invoicing to be done so that the money stream into the project company and also into the O&M company is secured. The second aspect is the settlement system must be accurate. We have to ensure that there are undisputed invoice amounts so that the calculations and the equations implemented in the settlement system are as per the requirements of the PPA or PWPAs. And this is supported through the audit process such system usually goes through, so that it is independently verified that this settlement system is in full compliance with the respective contract. Very important is the transparency of the data and the data treatment in the settlement system. This is particularly true if it comes to the invoice verification by the offtaker, because the live data which are sent to the settlement system to do the hourly calculations are sometimes erroneous. So the data may have to be adjusted, and those adjustments and modifications of the data have to be shown in a very transparent way so that it is convenient for the offtaker to verify the invoice. And that brings me to the next point, the ease of use. Because there is so many data in the system, it is very important to have a very intuitive interface so that it is easy to use for all the users, for those generating the invoice, for those doing the performance calculations, but also, and in particular, for those verifying that the invoice is correct and the adjustments have been done in the correct way. And finally, of course, accountability. The settlement system offers various functions and provides access to different types of data, from online metering data to availability declarations, and also contract data, like the charge rates specified in the contracts, but also the index numbers or exchange rates or whatever other numbers may have to be provided for the system to calculate the invoice. So for all those different categories of data, we have different access levels so that users, based on their role and based on their responsibility, can access the various data and have the ability to execute particular processes up to the final generation of the invoice, plus the approval of the invoice. So those are the key qualities we think are very important, and that's what we try to materialize in our settlement system. One important reliability aspect is the hardware. We are optionally providing a turnkey solution, so including the hardware, not only the software, but also the hardware. We have designed our hardware to be reliable for this business critical system. We will only use server computers with rate-configured hard drives, etc., so that the system does not easily crash. And from experience, I can tell we have not lost one single system during the last 16 plus years where we have worked in this field. So this is very critical for us. If we do not provide the hardware, we of course do provide the specification, so to ensure that the settlement system is operated on a reliable platform. One other aspect is we use an internal UPS for safe shutdowns and startups. So if there is a power outage, the system will automatically shut down in a safe manner, do not corrupt any data or databases. And it will also start back up automatically once the power is back without requirement of any user interaction. We have designed the system in a way that if it is shut down for some time, it is capable of reprocessing data from the past, which are received after the power supply has been re-established. So a shutdown of the settlement system is not an issue. because the design is such that it is robust enough to process the historic data which would have been arrived during that shutdown. And after data have been received, the performance calculations will be carried out by the system until the data backlog has been cleared. We are also always including an automated backup system, so that in case there is a requirement to reinstall the system, an backup will be available. But as I've mentioned, the system design as such is so robust that up to now, we were never required to restore the systems because system design was robust enough. With regards to transparency, I want to talk about the signal validation. Because off-takers must be able to review the data and trace back the inputs, and particularly they must be able to trace back if any adjustments had to be applied to the data. The reason is that metering signals are often incomplete or erroneous because of sensor or communication problems, or in case of a sensor recalibration, or an outage of any of the equipment or units in the signal transfer chain. So if the metering signals are not available for some time, the authorized user must be able to provide a replacement value for the system to be able to carry out the hourly calculations. And the signal validation dialogues, we will see a video in this webinar about the signal validation dialog. They are designed in a way that it is very easy to trace back any modifications which have been applied. There is a nice summary overview, so that it is very obvious for everybody, for those entering the data, for those adjusting the data, and also for those reviewing the data, if and when any modification has been applied. This is important because the invoice calculations are hourly calculations, so data must be available for every hour. And in case of a signal outage for some time, these data modifications are required to support the process of invoice calculation. With this, I want to start a short video showing you signal validation. In this example, we will see how we can correct signals. And bear with me for a second. The video will start in a very short while. So when you load, or when the user loads the signal validation dialog, this is done to review the quality of the signals. Of course, first thing is you would specify the time range for which you want to load the data. And once you're fine with your time range, if you specify the time range, you click the load or refresh button to load the data into your user interface. The signals with the erroneous data can easily be identified because of the red pattern of the signal. So you see the number of signal errors, and the details for this are shown in the detailed view below the summary overview. So the system is designed to pick the data in order of precedence. So there is the main metering data and the check metering data. And if main metering data is available and of good quality, the system will automatically use the main data. So even if check signals are missing, the system will not fail. It will just go with the main signal. Only if the main signal is not available or of bad quality, the system will automatically use the check signal instead. So if both signals, however, are incorrect, and this is the example you see in the current sequence of the video, then of course the system cannot tell what the replacement value would be. So in order to acknowledge the error and to provide an adjustment, you can change the selection to rechecked. Rechecked means you're acknowledging the error, and you can manually type in the replacement value if you know the replacement value for an individual record. You can, however, also load the replacement values into an Excel workbook from as a download from the DCS or as a download from some historic database. And if you know that, you can just copy the replacement values from your Excel or whatever other document, and you can paste the replacement value into the settlement system for the respective time slots for the respective records with just one mouse click. Of course, in this case, you would have to recheck or change the selection to reject for all the signals. So once you have corrected the data, you can save the data, and you will see that the number of errors in the overview reduces, and at the same time the number of rejections and adjustments have increased. You still see a red button in that signal. That means there is a few more errors to be corrected. And one thing which is also very important to know is you can easily find those errors because all the dialogues do come with sorting and filtering dialogues. I mean, in this case, I've made an example where it's very easy to see the errors right away, so that we don't have to look for things for too long time. There are additional dialogues like the raw metering data dialog, which do support you when it comes to signal corrections, because the raw metering dialog does allow you to show the cumulative metering data. And you can look up the cumulative metering data for a period where you're missing data in between, so for a data gap. If you get hold of the cumulative metering data, either from this raw metering data dialog, or you get hold of the cumulative metering data directly from the data logger or from the meter, you can again calculate the difference between the increment from the after the end of the gap and from the beginning of the gap, and then you can apply this delta as an adjustment value so that you fill the gap with the correct replacement value. And this is demonstrated in this Excel workbook where we calculate the delta, and then we go back to the validation dialog and we just apply the manual adjustment and distribute this across the number of records where we are missing data. So you just paste this in this dialog, paste the value in the dialog, and then you distribute the total quantity across the records. And you, of course, also have to acknowledge the error by selecting the reject option. Once you have done all your selections, you can again save the data back to the database. And now that we have corrected all the errors, you will see that the number of errors has gone to 0 in the overview dialog for this signal. And the red button has gone, which means there is no more error for this signal. and it has turned into a yellow background, so that another person who is opening this dialog will immediately see that things have adjusted, data have been adjusted. So for the ease of use, we have implemented some supporting features to make the corrections, the implementation of corrections very easy. So there are various ways of implementing the corrections. Because the time periods for with data losses may be very large, so it should at least be convenient to enter the data for such a big time period. We have included several methods to generate the hourly data. You can do it record by record. You can get hold of the various supporting values from within the settlement system, or you can also use external sources. And we have also allowed for a simple copy-paste from Microsoft Excel, so to make it convenient for users to transfer data, as I said, from DCS or from a historical database, which may be implemented at the plant site, into the settlement system. And we do use some color coding to make it easier for users to stay focused on what needs to be done before, in the end, and this is the ultimate goal, at the end of the month, an invoice can be calculated. I'm going to show you the second video about the meter deviation report. This is a supporting report which we have included in our system, so that you would see the difference between the various signals, between the main increment and the check increment, to allow you to identify quality issues of either the main or the check meter. So you can again specify a time range. You can pick any of the signals which are configured in the system and which are receiving live data. So then once you load the data, you can see that if there are records where the difference between the main and check increment, so the main and the check increment is the first two columns, whether they are beyond the limits. The limit is configurable, so you have a certain percentage of the maximum increment during an hour or during a 6-minute interval. And if the deviation between the main and the check signals is beyond that acceptable limit, then it will be shown as a violation. You can use the filtering options of the dialogues to easily find out how many instances of such a violation or excess signal deviations you find within a certain time period. So this is a very convenient way to figure out whether there is a significant amount of records which would require you to probably initiate a meter recalibration. You can also filter. You can filter for events where the deviation is, for example, beyond a certain limit, just to give you a feel of how good or how bad the deviation, or how good the agreement between the two meters, the fiscal meter, which is usually the main meter, and the check meter increment is. Next was accountability for the invoice generation. There are safeguards implemented in the system so that you cannot submit or complete an invoice unless the underlying data are of sufficient quality, of good quality. So if the data are incorrect or incomplete, you can not complete the invoice calculation. So there are pre-calculation checks implemented, so that to make sure that all the manual data and all the adjustments are provided, so that the invoice calculation can be completed. I've mentioned before, there is this rule-based authorization. So you can allow certain users to work on the technical aspects of the system, which is the signal validation, the correction of potentially erroneous metering data. You have separate roles for maintaining the fiscally relevant charge rates, or for maintaining the index figures, etc. So the different roles have different user accounts, and they have access to the various sections of the system. And finally, some authorized users are able to generate the invoice, and at an even higher level, you have users who can approve the invoice. For invoices which have been approved and submitted, they are right protected, and for the invoices, we also have implemented a version control. So you can never ever have the same invoice recalculated again. So each invoice does come with a version number, and this version number is printed on every page of the invoice. So it is ensured that one invoice document the off-taker is receiving from the generator is our pages from one consecutive invoice as calculated by the system. Finally, I'm going to show you a short video on how to generate an invoice. Let me start that video in a second. The invoice generation, once you have prepared all the data, is a fairly straightforward process. The user just needs to click this new invoice item. Then, of course, user needs to specify the start and the end time of the billing period. And usually this is one full calendar month. Depending on the requirements of the user, we either auto-generate the calculation date, or we allow users to enter the calculation date in a free format. We allow users to add notes so that the off-taker can be informed about any particular aspects to be considered when reviewing the invoice. And then you just click the calculate button, and the system will then automatically process all the data which have been received by the system, which have been corrected if that was required, and which have been entered by the finance department. The system, while calculating, will show you a progress bar so that you see how far the invoice calculation has progressed. And the invoices are also listed in the invoice list, so you have an overview, like an inventory of all the invoices which you have calculated so far, with the different states mentioned. So the invoice, when initially calculated, will appear in the draft status, and it can then be reviewed. After the review of the invoice, it can be approved, and then after the final approval, when the invoice has been cleared, it can be submitted to the off-taker. The invoices come with in various formats. So as the invoice document itself. So this is, the pages where you show the payment components only. So this is a document with the invoice page. Currently, as I told you, it is shown in a draft mode, and that invoice can then be reviewed. You can export the invoice in PDF. It comes with the basic supplemental documentation summarizing the key numbers which have been utilized and to calculate the invoice for that month. We also include a supporting document which shows all the details, all the hourly data, for some contracts even 6-minute data, And that document can also be submitted to the offtaker for their review. You can export the invoice document to a PDF file, and after the review, you can approve the invoice. Once invoice has been approved, you will see that the invoice document does no longer show the draft watermark, so that the invoice is clear to be printed, signed, stamped, and to be submitted to the offtaker. So that invoice report with no more watermarks is shown in the video right now. So then you can save this invoice to your local hard drive. You can print it, sign it, stamp it, and submit it as per your invoicing procedures. So with this, we come to one more aspect of settlement systems, which is performance models. One payment component, which is usually part of the overall invoice, is the payment for performance. This may be a fuel adjustment payment or the fuel payment. And the calculation of the fuel charges for gas plants or for oil plants is usually done or supported by a so-called fuel demand model. So the fuel demand model is based on the thermodynamic model, based on the Epsilon software. This is the software which Joseph mentioned in his part of the webinar, where ENEXSA is a co-developer of. So we are developing the plant to a great level of detail. This example is showing a plant with 3 blocks in one-on-one configuration. So we have the gas turbine, the HRSG, and the steam turbine. And obviously each of those sub-models includes the details of the respective component, like the HRSG does model each heat exchanger bank separately. So the different heat exchanger surfaces are modeled individually. For the gas turbine, it's not only a black box. The gas turbine is considering inlet air treatment, like evaporative coolers or inlet heating or whatever other method of inlet conditioning may be applied. The steam turbine, we are modeling each of the steam turbine spools separately, including any extractions or admissions. If that is the case, we do model the cooling system separately, but just to get a nice overview, we are covering those sub-models in separate views. So the thermodynamic model is capable of replicating the plant performance under all operating conditions and under all configurations. And that is the important thing why one would use a fuel demand model instead of just correction curves, because correction curves have a quite limited application. They are limited to certain configurations. They are limited to certain fuels, etc. Fuel demand model can cover everything within one model. So the fuel demand model is basically the twin brother of the physical plant, but just in the virtual world. Of course, the fuel demand model must accurately reflect the guaranteed performance. So the fuel demand model does not reflect the as-built performance, but the guaranteed performance, because this is the performance baseline for the plant. So, and depending on whether or not the actual plant is then performing better or worse than the fuel demand model, there may be bonus or penalty payments from generator to offtaker or vice versa. Such fuel demand model is usually audited by an independent third party. So they are using their engineering judgment to see that the behavior, the general behavior of the fuel demand model is as per engineering experience, and that the data which are calculated by this fuel demand model for the reference points are not exceeding the guaranteed values from the PPA. We also providing settlement systems for solar plants. For those settlement systems, we are including solar performance models. Those models are used, for example, to calculate the deemed production of electrical energy in case of a curtailment event of the plant. It is initially based on the contract values, but in the following years, we are then deriving the coefficients for the solar performance model from the historic data. And those data are then processed in a regression tool, which will then give you the model parameters for the coming years, so that the degradation as per the contractual agreement is being taken care of, and the model can be used for the entire term to calculate the missing data or the replacement values for deemed electrical energy in case of a deemed event. With this, I'm handing over to Joseph again to talk about the ENEXSA experience. Joseph.
Thank you very much, Peter. For the sake of time, I will make that a quick rush because we have 10 minutes left to conclude this webinar. In short, ENEXSA has been quite successful since the year we started in the settlement systems business, 2007. What you can see on the current slide under the column year, titled with year, that's the year of completion. So our first settlement system that we completed in the Middle East was the Fujairah 1 IWPP with Emirates Semcorp as the developer. And since then, we have been continuously working in the settlement business here in the Middle East. Also, in some cases, you see under scope just the term reference heat balances. This is projects where others may have provided the settlement systems, not us, but we have worked as a technical advisor for the project developers. The systems that we delivered are all still in use, and also 80% of our customers are under a technical support agreement to provide them with technical user support and software maintenance over the entire project period. So to complete our list of completed projects up to today, so the last project we have completed, Rabigh 3 independent water plants in Saudi Arabia with Aqua Power. In total, our settlement systems are covering a total power output of a capacity of more than 30 gigawatt and a water production of about 8 million cubic meters per day. The quality of our work and of our services may also be reflected quite well by a recent development where we have started to replace systems provided originally by others. The contract durations, as I mentioned, 20, 25, in some cases already now 35 years, of course, means that you have to live with the design of your settlement system and with the usability of your settlement systems. And we have seen that our customers have switched to our systems because they clearly saw value in our systems for the remainder of the contract time, even if it's not for the full contract period. We've also been successful across different types of plants, gas turbine based IPPs, IWPPs with thermal or RO desalination, solar plant, solar PV, as well as CSP. And we are very happy to also announce that we have received the first order for an independent sewage treatment plant in Saudi Arabia just recently for a project in the Dammam area where we are going to supply our settlement system for this type of public-private partnership project. With that, I want to quickly conclude this review of our experience because there is a few questions that I would like Theodore to moderate.
Thank you very much to Peter and Joseph for the great presentation. Now let's begin with the Q&A session. We have a couple of questions already. The first one we have is there any way to recover previous data after correction and saved?
Okay, let me answer this one very quickly. Well, as Peter mentioned in his presentation, it's actually essential that all data can be traced back. So we are actually never overwriting the raw data. What you could see in the signal validation dialog is that there is the raw signals and that there is adjustments. So the raw signals will always stay as they were, and only the adjustments are added. Either it's a full rejection or a partial adjustment, but it can always be traced back to the original raw data that come into the system. No data is overwritten from the metering and the DCS data as received. Peter, you want to add to that?
No, that's perfectly fine.
Thank you. Moving on to the next question is a two-part question we have here. You mentioned that you're using a thermodynamic model. Is this model validated with the correction curves provided? And what would be the reference for your model, the guaranteed values or the performance test values?
Let me answer this question. Yes, the reference values for the model are always the guaranteed values from the contract. So the performance test is then just for the acceptance of the plant, but of course the fuel payments must be in accordance with the guaranteed performance, and therefore the fuel demand model must be based on the guaranteed values and not on the results of the performance test. And depending on the contract, it may be validated against a series of individual data points. It may be validated against correction curves. So that really depends on the contract. But if the correction curves included in the contract, and if those are considered, part of the guaranteed performance as far as settlement or as far as the fuel component is concerned, yes, then a fuel demand model will be validated against those correction curves.
Thank you, Peter, for answering that. Moving on to the next question we have. Which metering data granularity do you recommend, hourly, 6MN, or others?
Let me answer this question. That really depends on the contract. If it is a gas turbine plant, we certainly do recommend 6-minute granularity. If it is a solar plant, then it is usually 15 minutes or 10 minutes, but usually it is 15 minutes. And that is good enough for solar plants. But for gas turbine plants, particularly those, where you can observe rapid load swings, the 6-minute granularity is much better because then you can do simulations for smaller time slots and you avoid the risk of constantly running into inconsistent data sets. For water plants, we can, depending on the performance model, it can be anything from 10 minutes, 6 minutes, 10 minutes, up to 1 hour. That really depends on the kind of performance model which has been agreed in the contract. So what we usually do before we offer a settlement system, we review the contract And depending on the conditions, we do recommend a certain data granularity. And of course, for some of the off-takers, the data granularity is fixed. So for example, Abu Dhabi, it must be 6-minute data. So you must comply with that data granularity anyway. But for other countries where there is some flexibility, we adjust it to the requirements of the contract.
Thank you, Peter. Next question is, any reference project on settlement system for CCGT configuration?
Well, many. If I can go back to the slides I showed on references for Theodore, can you, or can I go back?
Yes. What's the number of the slide?
Yeah, here we are. You see the slides? So there's many actually in the Middle East, mainly combined cycle plants. Initially, these initial IWPPs were gas turbine combined cycle based, combined with a thermal desalination up to the year of 2016-17, I would say. Thermal desalination, MSF or MED technology was the key desalination. After that, RO became the technical standard. The RO plants are running very reliably and more efficient than the thermal desalination plants. But there is also, and because of that, there's also now pure CCGT plants in the Middle East, so that independent RO plants and power generation are separated, and the off-takers are free to dispatch the plants separately depending on power and water demand. So there is many IPPs, also gas engine IPPs like the Mosandam IPP and Sur in Oman, Phoenix Power, that's a pure IPP. Also, we had some projects on cogeneration plants in Saudi Arabia, where the local utility and the local oil and gas company were supporting projects where the power and steam goes to the utility plant, gas cleaning plants, or petrochemical complexes, and part of the power is then sold to the utility, to the grid. So in terms of technology, we really cover the entire mix. It's also no problem for us to have a full mix with solar and combined cycle, or even biomass or coal in our models. Epsilon is very flexible in modeling such applications.
Thank you, Joseph. We have time for one last question. And that would be just a quick reminder again to all attendees, if your question was not answered today, this might happen on a later date, so please bear in mind that. And the question is, just a second, how do you engage off-taker consensus in the settlement system modeling?
Yeah, let me answer this. Of course, the buy-in of the off-taker is very important. So what we do, we start engaging the off-taker from the very beginning of the project, so from the functional design specification onwards. So we do prepare the functional design specification, which does already include a review of the contract itself. And we do present this to the generator plus the off-taker, and we discuss this functional design specification together with the off-taker. So we make it very clear from the beginning what the design will be like. We do also talk about the performance model. So we are very transparent on that, because what we try to do is we try to implement this in a fair manner, so that it just reflects, the clauses of the contract. And if if there is any discussion between generator and offtaker, we try to facilitate that so that there is agreement between all the parties, so that there is no surprise when it comes to the site acceptance test that the offtaker may be seeing something which is not in line, or which is in his view of not in line with the contract. So engagement of the offtaker from the very beginning is key to the success of such a project.
Thank you, Joseph and Peter, for this lovely Q&A session. Well, it was a great presentation. Thanks to ENEXSA for sponsoring this whole session. To our attendees, you receive an email shortly telling you how you can access the on-demand version of this webinar, or you can access this through our website, which is www.pmi-live.com/events. We look forward to sharing further webinars with you, so please do keep an eye out on the website I just mentioned. Thank you once again, and I hope you all have a great day. Thank you.
Thank you very much. Goodbye.
What a pleasure. Goodbye.